Okay, welcome to another fun edition of Math Concepts. So here we're going to look specifically at what's called the greatest common factor. And the greatest common factor is a tool that can be used in elementary algebra or more advanced algebra. One of the things that it's great for is being able to take equations or problems that are fairly large and shrink them down to something a little bit more manageable. So the greatest common factor is just that. It is the largest term or value that is common between sets. Now those sets of information can be anything from just a bunch of different numbers put together to actual equations where we're looking at terms. Now with that, your sets can also be just individual numbers on their own, or they can also include variables. Now when you're including variables, you don't have to include just one. You could include more than one or multiples. So it just kind of depends on the type of terms that you have. Now to find a greatest common factor really kind of becomes personal preference to you as you're working your math. You are going to decide as you go the different methods that you like or that make more sense to you. And then once you figure out the method that you like using the best, I would suggest that that's the method that you use every time. So what do I mean? Well, one such way to find greatest common factors is by doing something called listing out your prime factorization. That is a concept that we use when we're trying to find, say, your least common multiple. But here, if we were to use prime factorization, what you would then do is you would look for your factor or your term that is the same or shows up in all of your variables or all of the terms you're using. And then you would use the smallest value of its exponent. Whereas when we're looking at greatest common or least common multiple, we generally would use the largest exponent. So we're going to use prime factorization in a slightly different way. Now if you don't like prime factorization, the other thing that you could do is you could just simply list out all of your common factors or factors of each individual term and then identify the ones that were the largest. In other words, the biggest number or variable that was the same in all of them. I personally prefer to use prime factorization because sometimes you could be dealing with some fairly large numbers and they would have very lengthy factor trees. However, I will kind of show you how to use both approaches in these examples. So here I wanted to do a couple examples, and these first two, notice I just simply have numbers and that's it, and I want to find the greatest common factor for each set. In this first example here, I'm going to use listing out your factors. In the second example, I'll show you prime factorization. Okay, so here the method that we're going to use is essentially your factor trees. So how does this work? Well, you're going to take each number individually, so we can start with 25, and you're going to list out the factors of 25. So we have 1 and 25, and then we have 5 and 5. We also have 30, so here we would have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And then we have 75. So here with 75, we've got 1 and 75. We have 3 and 25. We have 5 and 15. So these would be your factor trees. Now the thing that we want to use is we want to look at what we have in common. And if you notice, in my 25, my 30, and my 75, the biggest number that I have show up in all three of them is 5. Therefore, my greatest common factor here would be 5, and this is what we'd be looking for. Now, if we're going to say use the method of prime factorization, then what that means is we're still going to approach by listing out factors. However, when we talk about, say, 44, the factors we list are going to be prime numbers specifically. So the first thing that I know is that if I look at 44, I can take out 4 and 11. That would be a factor. Now, 11 itself is prime, but 4 can reduce down into 2 and 2. So notice I've reduced this all the way down to the bottom prime. So if we take a look at what this actually is, this is going to be 2 to the second power times 11 to the first power. Now, I have to look at 66, and I'm going to do the same thing. I can pull out 6, which leaves behind 11, and then 6 is going to reduce down to 2 and 3. So if I look here at 66, I really have 2 to the first times 3 to the first times 11 to the first. Last, I have 88. So here again, 8 and 11. 8 can break down into 2 and 4 breaks down into 2 and 2. So again, if I look here, this one's going to give me 2 to the third times 11 to the first. So when we talk about what's in common, the first thing that I would note is that I have this 11 to the first in all three terms. So when I'm talking about greatest common factor, I know 11 to the first has to be a part of it. Now the other thing that I have here is I have this 2. So 2 shows up here, 2 also shows up in the second, and it shows up in the third. Now this is what I mean when I said in this case we are going to use the smallest exponent. So this one right here, raise each common factor to the smallest exponent on the list. So I have to the second power, first power, and third power. Raising it to the first power is going to be my smallest exponent. So this tells me I'm going to multiply this by 2 to the first. 11 times 2 gives you 22, and that is your greatest common factor, would be 22. Okay, so that's two different methods, the factor tree method and your prime factorization method, each of which gets you to where you want it to go, both of which two completely different methods to work with. So what you have to do is you have to be able to choose which method you like the best and use that method in order to come up with your result. Now the factor tree method is usually the simpler, more straightforward method to use. So I've got another couple other examples here, and with them I'm going to show you more examples of using that prime factorization idea, since that's the more unfamiliar method for finding a greatest common factor. So again, I have 16, which I have to break. So 16 can break down and become 2 and 8. 8 breaks into 2 and 4. 4 breaks into 2 and 2. So if we're looking at this, another way to identify your prime factorization would be to then circle your primes. And so for here, we would have that this is actually 2 to the 4th power. I then have 48. So 48 breaks down in a couple different ways. We know it can break into 6 and 8. I know 8 becomes 2 and 3, or 6 becomes 2 and 3, 8 becomes 2 and 4, and of course 4 becomes 2 and 2. So again, if we circled the primes, we would have 1, 2, 3, 4, and 5. And so here, if we looked at it, this would be the same as saying 2 to the 4th times 3 to the 1st. And then the last one we have is 56. So again, when we think about 56, one of the things that I think about is usually 7 and 8. 7 is prime, but 8 can break into 2 and 4, which breaks into 2 and 2. Again, if you circled your primes, you could look at what we have. And in this instance, we would have 2 to the 3rd times 7 to the 1st. So the first thing that we need to do is we have to identify which term we have that shows up in all. And the term that shows up in all here is this 2 piece. I have a 2 to the 4th and a 2 to the 3rd in all of them, which means 3 to the 1st and my 7 does not matter. They don't show up. And then of this, we need to identify the smallest power. I have 4, 4, and 3. 3 is going to be my smallest power, which means my GCF here is going to actually be 2 to the 3rd, which, when I do that math, gives me 8. Okay, so there again, prime factorization in order to find your result. Now, that same idea can carry through in a way when dealing also with variables. So here we have to look at 30 and x cubed. So when we look at 30, we know 30 can break down into 3 and 10, and then 10 can break down into 2 and 5, and so 2, that would be your bottom result. And then when I have 40, I know 40 can break down into 4 and 10, so 4 breaks down to 2 and 2, and 10 becomes 2 and 5. So again, here are my primes. So if I'm looking at my two values, I have 3 to the 1st, 2 to the 1st, 5 to the 1st, and then I have 2 to the 3rd and 5 to the 1st. Again, we need to identify the pieces that are the same, so I have this 2 and the 5. And then of those, you need to identify the smallest exponents. So when I'm looking at 5, of course, my smallest exponent is 5 to the 1st. And I have 2 to the 1st and 2 to the 3rd, so of course 2 to the 1st. So here, when I'm looking at just my numbers, my greatest common factor here would be 2 to the 1st times 5 to the 1st, which gives me a 10. Now, I also have to break down or look at what I have in terms of my variables. So I have x to the 3rd, which is the same as thinking about x times x times x. And then I have x to the 5th, which is again 1, 2, 3, 4, 5. So x, 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 x. If you look at what's in common with them, I have 1 on both sides, I've got 2, and I've got 3. So here my greatest common factor here has to be x to the 3rd. So when we actually look at your overall greatest common factor, we have to combine the two. So this becomes 10x to the 3rd. Now, just like before, another way that we could have done this, instead of using my prime factorization, would be to simply list some factors, or list the factors out. So here, if we were to look at 28, we would have to look at my factors of 28. So I have 1 and 28. Then I have 2 and 14. And then last but not least, I'm going to have 4 and 7. But then I also have c squared and d to the third. So then this would also include c times c, and then d, d, d. Now if I look at 14, I can look at the same thing. So I have 1 and 14, I have 2 and 7, and then I have c to the third d squared. So 1, 2, 3 c's, 1, 2 d's. Last, I have 42. So again, if I look at 42, I can break that down. So I'm going to have 1 and 42, 2 and 21, 3 and 14, 6 and 7, and then I have c, and I have 2 d's, d squared. Okay, so I've listed all my factors out. So here what we would then do is we would go through and we would look at what we have. So here I've got 1's in common. I have a 28 in my first, but it does not show up in the others. I've got 2's in common. I have a 14 that shows up in all 3 of them. I have a 4 in 1, and I have a 7 that shows up. So here we want to know the greatest. So I've got this 14 here that shows up in all 3 of my terms, therefore that would be your greatest value. And then here I have to look at the c's that I have. So when I'm looking at my c's, I have 1c, 1c, 1c. I've got 2 here. I have a second here, but I don't have any more here. And then my d's. So I have, here's a d, and a d. And then I've got a d, and a d, and notice I've run out. So if I'm actually looking at it, I would have 14 c d squared. And that would be your greatest common factor. Okay, so last but not least, I have this last term down here on the bottom. And so here again, if we take a look at it, one of the things that we could do would be to list out your factors. So if we started with 15, again we have 1 and 15, and we have 3 and 5. And then I have the number 4, so then that would be 1 and 4, 2 and 2. And in this case, if you look at these, notice I don't have any numbers in common with the exception of the 1. Now the other thing that I have here is I have x squared y to the 4th. So I have an x squared y to the 4th. And I have an x cubed y to the 8th. So if we take a look at them, I have 2 x's here. I've got 3 x's here, so the max that I can pull out when I'm looking at things in common would be an x squared. I have 4 y's and 8 y's, so the max I can pull out is 4 y's. So here my greatest common factor would end up just simply being x squared y to the 4th. So there you have it. Those are 6 different examples of being able to find your greatest common factor using either your listing factors method or using prime factorization. So if you have any questions, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.